All right, I think we are live. Um, cool. So I am Gaurav. I am the secretary of FRC 2813, and this is the monthly career panel. And on this career panel, we have uh, Chris Hondl, Dore Mark. Excuse me if I'm pronouncing it wrong. Doug Pargett and Andrea Chen. All right, so let's start off with the panel. First of all, can everyone introduce themselves, what their career is, and what is it about? So let's start off with Mr. Hondo.
Sure. All right. So I'm Mr. Hondl. I'm it's hard to describe exactly what I do. I suppose you could call me an entrepreneur. Currently I have a lead the engineering team for a software as a service company called Finale Inventory. We sell software to small businesses to help them run their e-commerce operations. We have about 25 people in the company, and about 12 of those are engineers that are on my team. So you could call my career entrepreneurship because I started this company and have kept it going with my partners for now over a decade. You call me a software engineer. I wrote most of the first versions of software. I don't write much software these days, but I lead the team and work with them on all the software aspects. And there's also another aspect called product management. And previously in my career, I was doing product management, which is about defining what the software needs to be and how to create software to be successful in the market. I did that at Adobe Systems before I was in my current company, as well as other companies. And that's actually a lot of what being an entrepreneur is figuring out what software is going to be successful in the marketplace.
All right, interesting. Mr. Mark, how about you?
Yeah, hi there. I'm Dore Mark. Let's see. I have a master's in mechanical engineering, with a specialty in control systems, control systems and mechanical systems, which is the old term for robotics. So, I've had a career in product design as a mechanical engineer, working over, I guess, 25 years. Like, it's been ridiculously long now. But I currently manage a team in China that makes medical products for the diabetes industry. Did that, started that company 10 years ago, and we do a lot of motion control, and we make insulin pumps for diabetes. So just to kind of give a little demo here, just a small demo. This is an insulin pump. What this does is it injects insulin into your body. It's wearable, and the device itself has a teeny tiny motor drive system, very similar to the system that you guys use in your project, except it's just ridiculously small.
Oh, that's very cool. All right, Mr. Pargett.
Yeah, so my name is Doug Pargett. I'm a mechanical engineer with the Monterey Bay Aquarium Research Institute. The acronym is MBARI. We call it MBARI. And what we are is a privately funded ocean research company started by Dave Packard in, I think, 1986 or 87, with the idea that ocean science is done poorly by doing it the same way it's always been done. And his focus was to invent technology to do ocean science rather than always go out there and do it the same way since the early 1900s. And in essence, what I do is I invent robots that go out in the ocean and explore it for science. Most people are familiar with autonomous vehicles, ROVs, remotely operated vehicles. Specifically, the equipment I design is microbial sampling equipment that can identify the algal blooms that are in the ocean based upon a DNA or RNA signature. And it does that all in the ocean autonomously in the middle of the night on a weekend and radios in the data to us.
Yeah, that's really cool, using science as well as engineering to make something cool. That's really nice. And finally, Miss Chen.
Hello, my name is Andrea Chen. I work in the semiconductor packaging industry. So we're part of the semiconductor supply chain that you've probably all heard about, the issues and so forth. and I specifically work for a company called Siliconware, or Spill. So I'm in part of the U.S. sales or subsidiary for the company based in Taiwan, who packages chips for a variety of companies like NVIDIA or Intel or Qualcomm. And I've been doing this now for over 30 years.
Cool. Yeah, looks like everyone has, lots of experience in whatever they're doing. So that's nice to see. We got very experienced panelists up here. All right. So next question. What led you to choose your career and what did it take to get there? Let's start off with Mr. Hondl once again.
Sure. So, yeah, what led me to choose this career? I think the big thing is, I like to make things. I like to create new things. I've always been very interested throughout my career in kind of coming up with new products that haven't existed before and, seeing them into the marketplace. Even when I was working at large established companies, I was always, kind of working my way into parts of the business that were creating new things. And I discovered programming specifically. I had programmed a little bit when I was in elementary school, but I didn't do much it really until I got to college. And it was freshman year. I discovered that, not only did I really enjoy programming, that I was quite good at it. And ended up getting a bachelor's in mathematics and a master's in computer science. So that was part of it. Part of getting here was definitely getting that solid, really solid educational background. That was certainly helped, but also that wasn't the end of it, because I've been doing this now. I'm over 25 years out of college. And, certainly the case in software that the technology is always changing. When I graduated, like the internet, as I should say, the World Wide Web was just kind of becoming a thing. The first time we got email was like people kind of used email on a regular basis. I think it was my junior year of college. This might be crazy to some of you who are younger, but like, when I was doing my undergraduate and my master's degree, most of the things that you take for granted were just coming into fruition. And so my whole career has been constantly learning new things. There's a foundational knowledge that you learn in school, but it never ends. And so that was a lot of what it takes to get here. And then on the entrepreneurship side, there, I think the big things, really come back to really learning a lot of humility, learning a lot of listening, learning a lot of trying to not work from my preconceptions about how things were, but to really understand and listen to people who had problems and then understand what their problems were and then how to solve them. I think I see often this sense of like, oh, I need to have this great idea to be successful, to create a new thing. I need to have this great idea. But in practice, it ends up being a dialogue with the marketplace, a dialogue with the customers. And you really have to, learn how to listen. And that took me a long time to kind of get to this mindset of like, I'm learning from the customers. I'm learning from the marketplace. I'm not the one with the answers, which is a little different than often it is in school, especially if you're a good student where, you look in the book, there's an answer, or if you don't know the answer, you can ask your TA. It's a little different when you're trying to create something new. And so that was one of the big things I had to learn along the way.
All right. Yeah, that was definitely very interesting. Thank you for the response. Mr. Mark?
Well, I started off my career, after college in Los Angeles, working at a plotter company. It's basically a large printer, lots of motion control and mechanical systems there. But then after a couple of years, I moved up here to Silicon Valley, which I think is a really special place actually, because Silicon Valley, there's really no failing here. I mean, if you fail, it's not a big deal, and I think there are a lot of places in the world where, failure is, something not desired, in people's egos. But here, you fail, you just go on to something else and you learn a lot. And it's definitely something that we have in our culture here. So, I kind of fell in love with making products. I did product design consulting for probably 15 years. Dell computers, Acer, lots of the old style computers nowadays, I guess you could say. TV monitors, stuff like that. So I learned a lot about manufacturing, and then worked at Flextronics, which is one of the large contract manufacturers in the world. They make a lot of products, kind of like Foxconn makes iPhones. Flextronics makes a lot of other products, consumer products. But then I fell into medical products and started a medical products company in China because there was opportunity there. And it's been the last 10 years now working with my company there with making insulin pumps and other devices for diabetes.
Cool. Yeah, that's a nice route to take. Mr. Pargett?
Let's see, how did I get to where I am now? Like many of the people here, from high school, I really wasn't sure I was going to college until I had a job at Burger King and realized that I could do math, and after that was motivating. After flipping burgers for about 8 months, I decided I was going to college. And being that I've always been building things since I could walk, and I come from a family with a lot of engineering background, I went for an engineering degree, started as an electrical engineer, and then by the second year realized I was spending most of my free time in the machine shop, not the electronics lab. So I switched to mechanical engineering. And this was a time when I took a typewriter to college. I didn't take a computer. Computers, we worked I could go to the computer lab and get an interface to the VAX. It wasn't bad, but it was, the Macs first came out when I was in college. After college, I was fortunate enough I got picked up by NASA because I knew AutoCAD. One of the odd little things is I knew AutoCAD from high school, dabbled in it through college, and was able to say I could drop right in and draft in AutoCAD. And so I got picked up by NASA at NASA Ames. And I was there for about 13 years. I built a lot of high power equipment, mostly reentry test facilities, some wind tunnels, a lot of very large motor systems, 2,000, 10,000 horsepower motors, that kind of level systems, managed projects. And then NASA entered, if you remember, in the mid 2000s, NASA entered kind of a downward spiral where they were actually getting ready to get rid of people, and they weren't building anything new. So I went back to grad school and took a class at Santa Clara University in ocean engineering, met a few people from Monterey Bay Aquarium Research. And when I went back to NASA, I was there for another year, and then MBARI called me up and said, "Hey, would you like to jump ship and join us?" And I did. That has been what can I say? That's been a eventful time. I guess I don't know what else to tell you about it. That's how I got to MBARI.
All right, cool. That's, really interesting experience. Just goes to show that, whatever small jobs you do, it always helps out in the end.
It was very motivating after that. That was beginning of junior year. And I opened my eyes and turned all my grades around. And it was like, okay, I'm going to college. And I grew up in a small rural community in Calaveras County that maybe 10%, 15% of the graduating high school was going to college. So it's a significant event in my life that I was motivated for it. The other thing you need to know is I couldn't become a pilot with the Air Force because I have color vision and don't have perfect vision. And so the Air Force says, no, you can't be a pilot. And I was like, all right, fine, I'm going to college.
Cool.
So,
all right, then. All right. And finally, Ms. Chen.
So I don't remember I don't know if people in the watching remember the space shuttle,
yeah.
And I remember when they first came out, the first ones when they did the test with the test shuttle, the Enterprise, and they talked about they had the ceramic tiles underneath. They could absorb all this heat, but yet you could hold the tile because the heat was all sucked into the core. I thought, oh, that is really cool. So basically what I got in engineering was cool tech. So when I originally got my started to major in engineering, I signed up as a engineering physics major, but then I discovered that I really wasn't that interested or that good at physics. So I was like, I gotta better find another major. And I had happened to take, I guess, the introduction to materials class at Berkeley. And the professor had a lot of interesting stories, probably because he did a lot of like expert witness work. And I thought, oh, material science, this is where I should go. So I have a bachelor's in material science and a master's in material engineering. And after I got my master's, I said I wanted to come back to California because I got my degree in the East Coast. And I wanted to come back to Silicon Valley because that seemed to be where the action was. And I ended up getting a job at this company called National Semiconductor, which no longer exists, and in their packaging department, because the old school way was you did everything. A company did everything. They made the wafers, the chips, and they packaged them and they sold them. But that's not the case anymore. So that's where I learned how to do semiconductor packaging. And then after about 8 years there, I saw that packaging was moving away from the companies to what they call outsourcing. So there would be companies that specialized in this. So I'm sure you've heard like TSMC is the biggest foundry in the world, the biggest producer of semiconductor chips. There are several companies who do what they call OSAT, outsourced semiconductor assembly and test. So I went to one company that no longer exists either, called ChipPack. And then I went to my current company, Spill, after that.
All right, and looks like Clement has commented something. Cool. Yeah. All the small experiences that everyone has built up, all the way from high school till now. I think that's helped, I think that helps build experience and, and it essentially just defines who you are. So it's nice to see. And what I also noticed was that everyone said that, or most people said that they ultimately ended up coming to Silicon Valley. And I think that just goes to show that, this is where we live, Silicon Valley. That's where all the big stuff happens. So that's another nice thing. All right, let's move on to the third question. What do you enjoy the most about your career? And is there anything that you don't like about it? Let's start off with Mr. Hondl again.
Sure. So, I think there's two pretty related things I like the most. So I'm going to take a pass and I'll give you two instead of having one be more than the other. The one thing I really enjoy about my career is kind of creating things, whether that ends up being creating software or creating a business that, we have, 25, it's a small business, but, a lot of people come to work every day and they can do good things. And there's a lot of customers that come our way and we solve their problems. But the sense of accomplishment by creating new things, solving problems, I think that's probably one. And the second is pretty tightly tied up into that, which is, the sense of, kind of knowing about and hearing about, how people are using the software we've created to make other wonderful things. Early in my career, I was, one of many engineers that worked on Adobe Photoshop, and kind of hearing the stories and seeing the marvelous creations people make with that software and the way that software, everything look around, you're always going to see images that have passed that software. And, having played a tiny little role in that, making that happen, I was just one of many, many people that worked on that software, but you could look around and be like, oh, we collectively, this big team kind of made this happen. Later in my career working, I actually worked for software for designing fireworks shows. And again, that sense of seeing a fireworks show and like knowing that you played a little piece in making that possible. I think that's a really neat thing, seeing the things that people create with the stuff, with whatever it is that you've created. That's always, I draw a lot of pleasure from that. And the one thing I really don't like is that often software engineering is a lot of, and I can't speak to other kinds of engineering, like programming ends up being can be at times a very solitary activity. You spend long periods of time, working with the code, trying to solving problems, which is fun, but I'm kind of naturally pretty extroverted. And so, after a while, that really does wear on me. So the times in my career when I've been exclusively doing, programming versus doing programming and a variety of other things, or like I'm now doing management, where I'm working closely on the technology directly with people, have been a lot better. It's just something to be aware of if you're thinking about programming and you're you just be aware that there are long periods of time that you do, solitary activity. And, it's just part of the deal. I mean, there's other types of software engineering, you can have other roles, maybe on the sales side, a sales engineer, where it's not so much, but kind of if you're building products, you're gonna spend a lot of time, writing the code. And if you're extroverted and get a lot of energy from people, that can get old after a while.
Yeah, I do software myself actually, and I can actually, yeah, that's very true. It gets really boring after long periods of time. And like, especially for me, like I just can't stand sitting at a desk for like hours and hours. So it does become boring at times. Um, all right, so how about let's start off with Miss Chen this time, just to mix up the order.
I would say the good part of my career has been like always there's always new things to learn, or there's always new developments and in technology, or new materials or new techniques or new kind of packages, and like what they call it, like cutting edge. So that's been interesting. I mean, a lot has changed in the last 30 plus years in semiconductor packaging. They went from wire bonded wires from chips to the lead frames, and now they do something called flip chip, where they have like tiny solder bumps over the bond pads on these giant chips, like for your graphics processor, and they flip the chip onto a substrate like a miniature PC board, and that's only really common maybe in the last 20 years. I mean, the technology's been around for a long time, but it wasn't like what you call mass produced maybe only in the last 20 or so years. I would say the difficult part, semiconductor packaging is a very small niche. It's a very small part of the semiconductor supply chain, but it's very important, but it tends to get overlooked. And I know in my work history, chips get designed and they try to say, oh, we made a mistake. Can you fix it in packaging? And then you're like, this is not gonna work, or this is, your yield's not gonna be very good, or we're going to have to do some strange things here. But a lot of times that they think, oh, you can fix it later if we messed up the chip. So that can be a problem. You get kind of overlooked in the design chain.
All right, interesting. Let's do Mr. Pargett.
Let's see. So what do I enjoy most about my career? There's, I'd say, two things I enjoy most. One is partly the reason why I left NASA to go work in ocean research is because it's an environment people aren't putting a lot of focus on. It's a kind of niche world where you're building robots out in the ocean. At least it was 15 years ago when I started this. There's a bunch more companies into it now, but you're literally working in an environment that very few people work in, specifically robots underwater, and those things tend to not mix too well. And that same nature, there aren't any off-the-shelf products. We can't just go buy a piece of equipment that meets what we need. Our goal, our drive, our purpose is to invent something new in this environment that very few people are working. And so that's a big drive for me. I enjoy that challenge. The second part is that we actually are inventing new equipment. When we start a new project, our idea is, hey, what if we could get data about, let's say you wanted information about how the microbial life is growing underneath the ice of an ice shelf as climate changes are affecting the way the ice is melting or growing during different seasons. And that they discuss that with the scientists, and the engineers have a blank sheet of paper to create whatever they want. You're not bounded by some limitation. You can be as creative, as inventive as you can be. And for the most part, as long as you're heading in a direction that looks like it's going to be successful, you get all the backing from the scientists and the founders and the founding foundation that you need to be successful. That's kind of what I enjoy most about it. Is there anything I don't like? Obviously every company, every job has things you don't like. The first thing is that although I live in the middle of the Bay Area, the company is in Moss Landing and it's an hour commute each way. Before COVID, we had a van pool that the company supported, and I didn't have to drive it each way myself, and I'm doing that now. That's not so fun. But inherently to this type of a job where we are merged with scientists, and the whole purpose of this is to have equal kind of status in the company, scientists and engineers working together to solve a problem. Inherently, we don't always say the same words. And our drive is not always the same thing. Engineers always want to make things better. We want to make a change. I want to change that. And a scientist says, if you change that, I do science with it, I can't publish it because you just changed the way I do my science. I have to do it the same way every time. And that is a mismatch. And the communicating through that mismatch is probably one of the more frustrating things at work. So.
All right, that's very interesting. All right, and finally, Mr. Mark.
Yeah, so I think I'll talk a little bit about earlier in my career. Before I started this medical company, I worked in product design. So companies like I never worked for Apple, but most people think about Apple product design as kind of the pinnacle of designing consumer products, because it's kind of a melding of art and engineering into a user interface that is well used by everyone, or easy to use for everyone. So I really like taking new technologies that come from different areas and then implementing them into new products. So for example, in my company right now, we're using semiconductor technology, thin film technology to make glucose sensors. And it's interesting to be able to be in Silicon Valley here, where we have all these great resources, to use some of the supply chain here, and then deploy those high technologies back in China into later in the supply chain to make the sensors. Now, one of the things that I really dislike, it's kind of a double-edged sword here. It's really great to work in a creative industry where you can create new stuff, create new products. Who thought of the iPhone in the first place, or just wireless devices, and how that would work. It's great to be creative like that, but at the same time, I've had to work with a lot of artists as well who have really no engineering bounds. They're just it's just their thought process, right? It's totally different. It's not grounded sometimes, and it's very difficult to work with people like that sometimes. I know a story about a guy who he wanted to create a new table that was an interactive audio table or something, and instead of like turning a knob to turn the sound up, he wanted to just use a motion like this. It's possible to do that, but I mean, and it's cool to do that, but is that really something that a customer wants? I don't know, but and then to implement it is not so simple, right? You have to put the sensors up and then code a bunch of stuff. I mean, it's not simple, right? So, anyways, that's kind of what I think about artists. I mean, I love artists. It's just we have to work together and find common ground in a lot of ways.
Right. Yeah. Everyone has their own mishaps at work, but ultimately, at the end of the day, whatever you're doing, you should, just like doing that. And it seems that everyone here, is really invested in what they're doing. So that's really nice to see. All right, let's move on to the next question. What do you do in your career on a day-to-day basis? And how about we start off with Ms. Chen this time?
Well, right now I'm working on basically I do what we call market research, technical research. So I help our sales organization, which is what essentially a U.S. subsidiary is, look at what's going on with our customers, potential customers, our competitors, what's going on with their technology, with their business, and write up reports for the president of the company so he can understand what the business strategy will be, going forward. So basically I surf the web basically every day, looking at for tech news and information.
Cool. And Mr. Pargett.
Day-to-day engineering tasks. For me, it depends on which phase of a project we're on. Like today, we are redesigning one of our pieces of equipment called an environmental sampling processor, which is this machine that goes out and collects samples and identifies the microbes by DNA or RNA. And we're updating it to work with a new cartridge that goes into it. And so I do a lot of SolidWorks every day. And that's this stage. Sometimes if we're at the beginning of a project, a lot of it is conceptual design and communicating back and forth with the scientists, with marine operations, and trying to just work on what envelope we're going to put this equipment, what it needs to be, how big, kind of defining the space that we can work in. That's probably my favorite part of this job, is defining that space that you can work in and then just throw all your creativity in. So some years it's like, that's all we do. I almost never even touch SolidWorks. Then there's other times where after the models are done and we've thrown things through the machine shops and the 3D printers have done their bit, all these parts come in, and we're a relatively small institute. So most of it's me doing this, assembling things, fitting stuff up. I don't do the circuit boards. If I touch them, things tend to go wrong. So we have electrical engineers that do that. And so there's a window of time that we're doing mostly mechanical assemblies. And then there's the whole integration and test, which sometimes takes months, where every day you're in there running another test on the system, making a small mod, running another test, running another cartridge, running it at pressure, running it in the cold chamber because the ocean's colder than the nice lab, putting it under pressure in the cold chamber. And then once you get to that point, you're also in the let's start fielding this. Now, we have our own marine operations that fields equipment when it's kind of perfected, but the initial deployments, the engineers go out with it on the ships and we deploy the gear over the side, and as best as we can, help it through its operation, take as much measurements as we can to try to determine what's working, what's not working, what we need to change. So our day-to-day operations are never consistent throughout the entire year. It depends what phase of the project you're in.
All right, Mr. Mark.
Yeah, so that's a good question. What do I do every day? Well, my company's in China and I'm the only representative here in the US. So unfortunately, I haven't been able to go to my company for the past 2 years almost now. And so I usually sit on Zoom just like this, talking to my team. Luckily, I have some good engineers and good engineering managers there who do most of the day-to-day work. But when it comes to, a creative problem that needs to be solved, they'll bring it to me and then I'll review their work and make some suggestions on what they can do. So that's kind of, the core part of the job. But lately, actually, because I'm in the US, I have to work through some of the United States FDA regulations because it's it's a medical device, which is highly regulated worldwide in different places. So, there's FDA regulation, there's CE regulations in Europe, and then there's China regulations themselves. And the way that the governments handle those requirements are totally different. They're very similar, but different in many ways. The FDA is actually very, 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 very stringent, extremely stringent, and it's the gold standard in making medical products. So I find myself teaching the team quite often, what they need to do to meet the medical regulations in the U.S., which requires a whole lot of paperwork and a whole lot of requirements writing, and a whole lot of validations and verifications, testing. And I don't mean testing like you guys probably do on your robots. I mean when you test it, you write down what you did, you write down exactly the procedure that you did, and you show data and you make reports, and it's insane. It's absolutely insane. And then teaching people overseas how to do it is even more insane, especially when none of them speak English, or most of my team does speak English, but there is a little bit of a simple language barrier there. So like just before this call, I was talking about how they're going to do the cloud HIPAA requirements. HIPAA is the privacy requirements that the U.S. has for taking medical data in the cloud, and we have to have like requirements and verify the requirements and SOPs like procedures and such, to make sure that the data is handled appropriately and not against the law. Otherwise, our products will just get pulled from the market. So that's what I've been doing lately. It's not really engineering work, but it's related, because you have to have a real technical background to understand how the products function, and how the regulations can be met by the requirements and the way that the products are designed.
Yeah, it definitely seems like there's like a lot of thinking and other stuff in the background that goes on when it comes to doing stuff like that. And finally, Mr. Hondl.
Yeah, so career on a day-to-day basis. So our company is fully remote. So there's a lot of Zoom. We've been fully remote since we basically started building up the team. And we actually have people across North America, South America, and Europe, kind of people a little bit all over, and India as well. So we've got quite a broad spectrum. So a lot of time on Zoom. And, at this point in my career, with the way things are now, I kind of alluded to earlier, I'm not doing a lot of software engineering specifically. I don't drop in and write code on a regular basis. That all kind of went by the wayside when we went from, I probably went somewhere when I went from about 4 engineers to about 7 or 8 engineers. That was kind of the end of writing any code. And so I work with people. I work with people on very technical subjects, and on very product centric topics, but it is definitely people. So one thing, of course, is when you build a team, you need to, understand all the people on the team. You've got to think about, what do these people want? What are they looking for? What personal crises there happen. I've been amazed in my career at the amount of, you wouldn't believe all the different things that happen to people once you have a dozen people working for you over in the course of a year or two. And some of it comes into work, and you start to learn how to, talk to people about that. And so that's been actually really interesting. But it's part of building an engineering organization that you might not realize. You also working with my co-founders. I've been blessed to have folks I've worked with for, in one case, over 20 years on different projects, and being able to build long-term relationships. Again, kind of coming back to people, being able to have people that you can work with over a long period of time is really helpful in terms of, creating something meaningful and lasting. So on a day-to-day basis, I'm thinking about, what are their needs? Again, thinking, what are their needs? What are they trying to do? What's important to them? What's important to me? And how can we collaborate in a way that's going to be the best for the company? So again, a lot of email, a lot of face-to-face meetings. And then I do a lot trying to understand the customers, the market, the competitors. So I either through firsthand interviews with customers, or I look at information we're seeing on our support ticket system or in our sales process, trying to synthesize that, understand what competitors are doing, understand what's going on in the marketplace, and think through all of that with a deep understanding of the product to figure out, well, what should we do? What should our product be that will kind of produce the best result for our customers and our business? And that's really interesting because there's always so many ideas, in the kind of businesses I've been involved with. There's way more ideas about what we could do. And the trick of it is try to figure out, given you've got people and the time that you have, your limited resources, what's the best thing you could do? What's going to have the best result? And so that's actually a really, I find to be a very fascinating problem, and does require deep expertise and experience, on the engineering discipline, because you need to make guesses about how long things are going to take, about how hard certain problems are going to be, because you're trying to optimize, what set of projects are we going to work on that are going to have the best chance of succeeding relative to what's going on in the customers and marketplace. So a lot of thinking and then communicating and selling that idea. One thing that's actually kind of I don't do, which happens for most people, I would say, is we don't have a board of directors. I don't have a boss. Unlike if I was at a big company, I don't actually, my partners and I own the business, and so that's actually kind of unique. Something I don't do. Most people, unless you're kind of in the position of starting and owning a company, you'll spend a lot of time, understanding what the needs of your boss are, or the needs of your, other people in the leadership or the board of directors. And that's actually part of the day-to-day work that I think you often will have that I actually don't have.
Interesting. Yeah, everyone has their own unique things. Cool. All right, and we are on our final and last question now. Looking back now, is there anything you wish you had known before entering your career? And are there any particularly important skills to have for your career? And let's start off with Mr. Mark.
Wow. I would say the number one thing, as an introverted engineering kid in college, actually I wasn't that introverted, but as a stereotype goes, right? Developing communication skill probably was the number one thing that most engineers didn't think about doing, right? So I never hung out with the engineers actually in college, but definitely, being able to communicate what you do, what you need, working as a team, becoming a leader as well, learning how to lead groups and take everyone's inputs. Those are the things that I would have developed earlier if I'd known. I think I did it, but I didn't consciously do it. It's something that I think that everyone should do anyways.
All right. Next, let's do Mr. Pargett.
Yeah. So looking back now, let's see. Definitely getting better at communicating with people, especially in a technical realm. It's less common in the engineering world for people to publish articles and put their information out there. At least it was, than it is for science. Science, you're not going to get anywhere unless you're publishing. For engineers, it's a little less common. And in this kind of position, we kind of have split the duties at work. I publish, technical notes and stuff. I'll go to conferences to present how my equipment works. So then the scientists can publish their science and just reference my publications for explaining how this new piece of hardware works. And that would have been valuable even when I was at NASA, is being able to, whenever we develop something new, to get that information out to the world. But it is also kind of building your own brand as your capability of an engineer. And so you get known further and beyond your own immediate group. That would be useful. And also important skills. The important skills people have, because remember, like I said, I started college when I took a typewriter to college. We were still reading the color bands on resistors. HP calculators still clicked when you pushed the buttons. Cell phones didn't exist. I had an email so I could log into the VAX machine, and I had to explain to people what email was. So everything is changing, and it's changing faster and faster. And so being highly dynamic and understanding the way technology is changing. As a good example, one of the ways that Embari got into 3D printing was one of my projects where I said, I have this complicated part and it's critical to making this new ocean sampler work. And if it can do this, we can create something wonderful, but we can't machine it. We can only 3D print it. And they said, okay, well, we'll do this. And the Packard Foundation supported us, and we were able to get our first 3D printer, and it worked. And then, 8 years later, we've got several 3D printers, and half of what the mechanical engineers are making goes through a 3D printer. and your whole mindset has changed to where you're not just handing off this drawing to a machine shop, you're creating it in CAD, it comes out of the printer, you'll modify it, and your entire approach to engineering has changed. And that dynamic, you have to stay in the loop of where manufacturing industry is going. Because if you get out of that loop very quickly, you're behind and you're like, well, why aren't we just sitting there looking at the mills and manually turning the knobs? Why do we have CNC? Why do we have 3D printers? And then the other bit I would say, the particular important skills that I see with people all around me at work, they have three things. They have energy, they have creativity, and they have perseverance. When you're working on the cutting edge of tech, you have to have a lot of perseverance, and you've got to have nearly stubborn perseverance where there's a problem and you're going to stay there late. You're going to work there on the weekend and you're up at night trying to figure out how you can make this item that has to be only so big withstand so much pressure and so much force and not corrode after a year in the ocean. Those three things, energy, creativity, and perseverance, is pretty key in the ocean industry.
All right, thank you for the response. Let's go with Mr. Hondl.
Yeah, this is a tough one because there's like so many things. But I think I can echo a lot of what Mr. Mark and what Mr. Pargett said. Although a little side note first. So even before entering the career, I guess this counts because it is before I did turn my career that I wish I knew. When I was in college, I didn't really take advantage of college in the way that you could. I had, I was lucky enough to be at school, had some truly outstanding professors. And I never did some of the activities I could have done to actually start to build a relationship with some of these professors. Maybe not a relationship, but just learn from them. I was at Stanford. I had John Hennessy, who, was one of the co-inventors of RISC processing, teaching microprocessor design. I could have popped into office hours and said, hey, tell me a little bit about what you're working on or what you think is interesting. I don't even need to have a question about my homework. You can go in and just, if you ask someone about what they're working on or what excites them about what's new in the field, that's a perfectly valid thing to go to office hours and ask. And I imagine that many professors would be excited to talk about their research. I also had Mendel Rosenblum, who was one of the co-founders of VMware, who was at the time a professor working on figuring out how to do virtual machines on x86 processors before anyone had come up with that. Again, could have gone in and asked that. So I would say when you go to college, don't think of office hours and think your professors just in the scope of what they're teaching in the classroom, but, just go in and think of them as people that you could actually meet and ask some questions about what they're working on. And you might learn something and, maybe you'll build a relationship along the way with one of them that'll lead to some pretty interesting things. So that would be that's something I always tell anybody going into college. But yeah, just to echo what Mr. Mark and Mr. Pargett said, so much of what we do is a people business. I've sometimes people who are doctors or lawyers will ask me about what it's like to be in software engineering, like school events. I'm like, yeah, it's a people business. They're like, what? I thought it was all about tech. And like, no, it's all about all the people and how do you get a bunch of people going together in the same direction? Or if you're part of a team, how do you understand the direction and do your best to kind of go in that direction? And so that's, it's really different than school. Again, something, I was a pretty good student. It was a really hard transition if you're a good student. And I think a lot of FRC kids are good students. You're good at school. You're good in a world where what you do personally results in good grades and you kind of follow that treadmill. And then you get in a world where it doesn't really matter what you do. It's what the team does. And that's a pretty big transition to go through. And I think it can be, I know it's hard for me. So that's another thing to be thinking about, getting used to the idea that, the accomplishments come from the group, not from the individual. I think in FRC that's a good place for that. But, just kind of understand that the world of I'm going to do well in school and I'm going to get a nice grade at the end of the quarter, that kind of comes to an end in a couple of years. And, think about that in your future. Again, to echo what Mr. Pargett said, perseverance. How many times have I been sitting there wishing I could go ask the TA for what the answer was to the problem set? There is no TA, there is no teacher, there's no professor. You got to figure it out. And sometimes it seems just impossible. And then specifically for computer science, I know I'm rambling, but specifically for computer science, computer science is really popular right now. It's one of the most, a lot of schools, it's one of the biggest majors on campus. It's hard to fake, I think, being interested in computer science, because there's always other folks who really are interested. And so, think of it as a field you should go into if you really like it, because the people that are really interested are going to do more, and they're going to work harder, they're going to learn more. So, it's the kind of field that, go into it because you actually really like the material, not just because you think you can get that job at Google or Apple or something like that. You have to do more than just go to class to get the good jobs. FRC is a great start in high school, but once you get into college, keep thinking of activities outside the classroom to kind of keep pushing yourself. And then we get on the industry, to echo what Mr. Pargett said. If you fall behind, the industry is going to push you out. So like, if you think that you learn something and you get comfortable and you think you can do that for 5 or 10 years, it doesn't work like that. So you just know that you're going to be on a treadmill as long as you're in the industry, of always learning, always finding what the new thing is, understanding what it is, and figuring out how to apply that to problems in your workplace. And if you're not, if you're not that interested in the field, if you're not willing to sign up for that, it's a pretty tough field to be in, because again, you get pushed aside. I saw, I was at Adobe, and people had been there early on, and they'd been working on printers, and the company went a different direction. And these people had thought they had a great job, and then they just got let go after a while because they hadn't stayed current. And that's how the world works. So, just be aware of that. And I think that applies to, from what I can tell from the conversation, to most of the tech fields.
All right. And finally, we got Ms. Chen.
So I would echo what everyone else has said about communication skills. I think people don't realize that you end up writing, I guess, a lot of reports, or you have to do presentations in front of your peers, your team, or if you go to conferences, or if you do, write for journals or so forth. So yeah, I would say emphasis on like build up your English skills. I know how painful English classes can be in high school, and then if you have to take them in college, they're no fun. But being able to communicate ideas and make logical, conclusions is a really important thing, a skill to have. And I guess the other thing I would say is also, as people said, team building, relationships. I think that will help you, get ahead in school and in industry, especially whatever your first job might be, especially if it's a very large company. It's almost like in a sense, like a graduate school, because you'll probably meet a lot of other people roughly the same age, and you'll make a lot of connections. And then eventually a lot of people, disperse to other companies, other places. And so it's good to know people in other places when, maybe your current job isn't so great, or you want to have a new opportunity. So yeah, I say relationships and communication skills are 2 great things to have.
All right, cool. Thank you for the response. And it looks like we have one more question. And it is. All right, yeah, got the question. What were some notable projects you have done throughout your career? Yes, just another question that popped up. Let's start off with let's do Mr. Pargett first.
Notable projects in my career. So one of the interesting things working for a developmental research company is you'll build things that you'll use and you'll demonstrate, and it'll never become a product. And one of these things was we were taking the second generation of this environmental sampling processor that could work to maybe 30 meters deep in the ocean, and we wanted to use it in the very deep ocean, 4,000 meters down, where the pressure is quite high, 6,000 psi. And part of this was, how do you take this piece of equipment that works in shallow water and put it in the deep? And that ended up being a quite exciting, fun time, because I spent the next 2 years inventing this complicated system of a giant meter diameter titanium sphere and a lung system that, like a hydraulic lung, that would inhale 10 liters of water, decompress it, and then feed it to this low pressure instrument, and it pretty much based like lungs, and then empty out that sample and redo it again, all on a platform that you carry out on a boat. I spent 2 years building this piece of equipment. We carried it out on a ship over the channel, over the deep canyon in Monterey Bay, and dropped it. Where it free falls to the seafloor. I spent 2 years with this thing, and we literally throw it in the ocean. And yeah, and after a year or two of diagnosing problems here and there with it, and iteration and test, we get the thing working. We take it to a cold seep. We take it to the methane mound off of Southern California, do some science with it, demonstrate we can detect bacteria that's coming out of thermal vents, or not hot vents, but they're called the cold seep. Their thermal vent fluid is mixing with seawater and then coming out in a little slower area where there's tons of bacterial mats and lots of things live there. And we can detect those microbes. And it was like, yeah, this is going to be awesome. And yeah, nobody can afford it. No, we haven't deployed it again yet. But that was so far, that's been my favorite project, because that was a full open creativity. How do you put this thing in the ocean, and how do you give it water that's 6,000 PSI and not have it just explode inside?
Great. Let's do Mr. Hondl.
So what was the question again specifically? It was projects that were interesting.
Yeah. What were some notable projects that you've done throughout your career?
I'll pick two. I think probably the most interesting. So the first was fairly early in my career. I was probably 3-4 years out of college. I was working on an engineering team at Adobe Systems. I alluded to this earlier, and we were working on a project that was not part of Photoshop, but it was a separate project. And this is when the web was first becoming a big thing. This is about 1998, 1999. Photoshop at the time was very print focused, and we basically got, our project got canceled. We got merged into Photoshop and became Photoshop 5.5. And it was really notable in the sense it was the work that about 8 to 10 of us had done together ended up being a key piece of what was able to allow Photoshop to transition into being a web product. So for a long time, there's a dialogue called Save for Web, and anytime you would save it, for a long time, anytime you would save a GIF or a JPEG out of Photoshop, it was coming through some of the, for the web, you would actually be going through stuff that I'd worked on. And that was I thought that was pretty notable, because, there's a period of time in the early aughts where, kind of worked on something that was used for a lot of the imagery you would see on the internet. Certainly anything that was processed by hand. And the other one is more recently, when we started my current company, we started out designing, horrible business, not a great business idea, but it was a really cool product. I created a product for designing fireworks shows. It wasn't what we thought we were creating. That's a longer story, but that's what we ended up creating, and ended up being, over the course of between 2009 and roughly 2013, basically became certainly the most widely used product in the world for designing fireworks shows. We ended up working with folks. It's ended up being translated into a dozen languages. It was kind of the de facto standard throughout like South America. It was very widely used in the United States. It was in China. We had a Japanese distributor. It was just 2 of us. And it's kind of a neat thing to kind of go out and be in a position of being like, there's all these fireworks shows people go see all around the world that were designed. And then there's a lot more that goes into actually executing one of these shows in software that basically I had written with my partner. I haven't personally worked on the new version. Things happen, but now, that product lives on and is used. If you saw the Olympics, if you saw like the Super Bowl, if you saw the inauguration, all those shows had been designed in the software that kind of came out of what we created 10 years ago.
Cool. All right, let's go to Mr. Mark.
Wow, so many. I'll try to focus on a few. So, as I mentioned, the first part of my career was doing design consulting, and I worked at a company called Frog Design, which is the design company that created the Macintosh for Apple. Guy moved from Germany. Steve Jobs had Hartmut Esslinger moved from Germany to Silicon Valley, and I worked for him for many years. And we did stuff like I mean, you wouldn't believe it. I mean, we were checking, whether or not Disney Cruises could make a ship hull in the shape that the artist wanted. And you have to realize in that design consulting role, the engineers were the translator between the artist and the engineers at the company. So we worked with a lot of people at Dell, for Dell Computer and Packard Bell and Acer and all these computer companies, just making sure that the artist's vision could be implemented in CAD, and then the engineers could take it over either in China or at the company themselves. So I worked on stuff like Guitar Hero, video games, stuff that you used to see at Fry's. I mean, it was really cool to be able to see your products at Fry's, during Christmas. Like, hey, I worked on that. Or you go to the Consumer Electronics Show and see a TV and go, oh yeah, I worked on that TV. Just so many. I mean, at least five projects like that per year. But I mean, not in depth. I mean, we didn't design the actual TV. We're designing the bezels and the shapes and making sure we can hand it off to the other companies. But more recently, I worked on a robotic surgery table a few years ago. When you do surgery, they use X-ray machines, and X-ray machines cannot have metal around them. So we had this robotic table that would be able to move the patient around and image them in different positions without any metal in the middle. So all of the mechanism had to be on the head side and the foot side, all carbon fiber. So pretty interesting there. But most recently, it's my company right now in China. We make diabetes products, and we're at the cusp right now of making the artificial pancreas. So diabetes is a disease where you can't control your blood sugars. And the way that it's done right now is people will prick their finger to do a blood glucose test, test how much glucose they have in their blood, and then have to manually inject or pump to inject insulin into their bodies to keep their blood glucose low or in a standard range. And since our company is one of the only companies in the world that actually makes all of those products, the blood glucose meters, the insulin pump that I showed you, and the CGMS, which is a continuous glucose monitor that you wear on your body, we're going to be able to, in the near future, be able to automatically control your glucose just by a sensor and pumping insulin into your body. So something that we're working on in China, and the next generation of products that we're working on, we're finishing those up, getting more investors. Actually, we just raised quite a bit of money, and trying to get through the regulatory process, which is my headache right now.
Yeah, that's just a nice list of products. Seems really interesting. And finally, Ms. Chen.
I was just thinking about what interesting projects have I worked on in the past. It's been a while, but a long time ago, when I was at National Semiconductor, there was National Semiconductor was known for their analog chips, and there was a chip. I don't remember the product name, but I think it had a voltage problem where, because it was molded in plastic, the contact of the plastic on part of the chip, it caused the voltage to drift, and they couldn't sell it. Then they had to bin it. So you had different bins, and you could sell at different prices depending on the range or the quality of the chip. So the product group came to the packaging group, said, we need help. How do we solve this problem, since we can't respin this chip, this device? And so we came up with the idea of putting a drop of silicone inside on the location where the voltage, change was happening, and then overmold it at that point. So we helped get a machine, we got the material, and then we wrote a spec to describe how this is going to be done at the factory. That was pretty interesting.
All right. And it looks like we have one more question from the YouTube chat. And all right, let me just. Yeah. Did you have a mentor? And if so, what is one thing you learned from them? If not, what do you wish a mentor could have taught you? And let's start off. Let's just do Miss Chen this first.
See, do I remember? I guess you could say my current boss is my mentor, or I guess he recognized in me that my ability to, I guess, write well. I've written several papers with him and for him, and also in our, the different companies that I've worked with him. I met him. He became my manager at National Semiconductor, and then he's currently the president of the sales organization at Spill in the U.S. And so I write reports for him. I've written papers with him. I've even written a like introduction to packaging book with him in like about almost 10 years ago, 12 years ago. So he's helped, I help him, I guess, communicate to the outside world his message or his vision.
All right. Thank you for the response. Let's do Mr. Mark next.
So lately I don't have a mentor right now, but I would say though earlier in my career, there was a guy that helped me out at Frog Design and subsequently at other design firms. He basically showed me how you can really go out on the limb, try something crazy and just back it up and don't fear failure. He also basically made me for many years do Pro Engineer or PTC Wildfire, which I know Doug over there, with SolidWorks. I've done SolidWorks too. I literally did my 10,000 hours on Pro E-surfacing, and making all those crazy forms that you see in consumer products. I'm still an expert at that, and I still do that work for my company, even though I manage the whole teams that implement this stuff. They give me like something functional and then I make it beautiful and send it back to them. Mentors are important. Definitely someone, who you look up to and who you want to be like, in the future can really help you be successful.
All right. Let's go to Mr. Hondl.
Yeah, I can't say I've really had someone who I think of as a kind of a mentor on an ongoing basis. I think I kind of regret that. I think there's definitely times, and especially early in my career, where I could have used some more mentorly like advice. But especially those years that I was at Adobe, I was there for about 8 years, kind of navigating, learning what it was like to be a company. I was kind of like a bouncing around from group to group, and never really, had someone I could, kind of talk to on an ongoing basis. So not really.
All right. And finally, let's Mr. Pargett.
Yeah. So when I was at NASA in the 90s, there was a mentor program for fresh outs of college, and it was pretty good. It was a formal program. And fortunately, the mentor I had was good at also not just advising engineering and advancing in the way NASA had a structure for it, but also engineering in general and life approach and balancing your work-life balance, and that was really valuable. But then you get to a kind of mid-senior level of engineering and the mentors go away. It's not they go away. You're all kind of at the same plateau, and you're at a realm where people are moving into upper management, middle management, and they're no longer the technical experts. So they could still give you advice on things you could do for structure within the company. What could you do for organizing a project? But they're no longer the technical experts you are. And so I was kind of the same thing when I went to Ambari, is that I went to Ambari at a mid-stage career rather than an early stage career. And there were some people that I wouldn't call them mentors, but I'd go for them for advice. especially on technical things. Like, what do you think about this? You know, what do you think about this? What do you think about this? And mentoring is really kind of critical once you understand that it's helping people find their way inside an entirely new environment, whether they're coming in at, 20, 30, 40, 50, or even 60 years old. They're still entering a new environment, and they could use help finding a pathway that is not just successful in that environment, but also successful for them. And so it makes it like a partnership. And that's why I kind of went on this long path. The first mentor I had at NASA was pretty good. The second mentor I had, we were just on different wavelengths. They were headed into the management structure, and their goal was to go to DC and head up a major department in DC. And my goal was to invent things that, were going to put people in space. They were two different goals. We didn't have the same future. And so that's where mentoring doesn't work. It really has to be a partnership between two people that get along and have a common goal of what that person is interested in. And it doesn't have to be formal. You can get mentors in your personal life. You can get mentors from people who are younger than you, who are like, oh yeah, totally. This is exactly how we do things in college now. We haven't touched that system in 10 years. Why do you bother with that anymore? So mentoring is a 360-degree approach, and we can all benefit from it.
All right, thank you for the response. And it looks like we are done with all the questions. So, just wanted to say thank you, everyone, for giving your insight into all these different careers. It was really fun for me asking these questions and then learning about all the different careers and all the experiences that come with entering these careers. So I just want to thank everyone for that. And yeah, that's it. For everyone watching on YouTube, make sure to tune into the next career panel, and that should be it. Thank you, everyone.